Hi, everyone. First of all, let's just want to say thank you for joining and taking the time to attend our session. And today we're here to talk about cloud mesh and potential different solutions. I'm Frank, and this is Jacob.
Hi, Frank. Hi, everybody. My name is Jacob. And I first wanted to ask, who has heard of HAProxy before? It's a lot of people. And who uses HAProxy right now? Awesome. So some of you see my colleague in the back. We have a T-shirt for you. Thank you for using HAProxy. If he runs out, then please see us at the booth, and we'll get you one.
All right. So for today, we wanted to talk about multi-cloud chaos, the unified cloud mesh architecture. We want to tell you some tales of the field. We work on the enterprise side, and we talk to a lot of different enterprises, and they're looking at service mesh solutions. So I'll start with a statement. The service mesh was designed to solve connectivity. However, for most organizations, it's simply shifted complexity elsewhere. Let's dive into some of the issues that we've observed. If you look at today's modern infrastructure, it's fractured. It wasn't built, it evolved. There's multiple clouds, multiple regions, on-prem data centers, legacy applications that can't change, and most service meshes weren't built with this in mind. They struggled to integrate the brownfield enterprise. Then you have the mesh stacks. The two most prominent architectures on service meshes, you have the sidecar architecture and the sidecar-less architecture. When you look at the sidecar architecture, it's basically one sidecar per pod or per instance of your service. And this simply becomes too expensive and complex as you scale. Then you have the sidecar-less architecture, which is better. However, complexity is shifted elsewhere to different components. You have the layer 4 proxy, usually per node, and then you have layer 7 proxy, which is a layer 7 proxy, so it's split into distributed components, usually per namespace or service account if you're using Kubernetes and these types of things. So it's less overall, but there's still operational complexity in dealing with that. And crucially, both architectures still fail at preventing resource sprawl as you scale, managing north-south traffic, they primarily focus on east-west only, and federation or multi-cloud region setups have difficulty or are emerging right now. They require additional components or were not considered with the initial architecture. So the problem isn't the service, it's the boundary. We've been hyper-focused on services, but the real challenge is the network boundary. What if we stopped trying to manage sprawling sidecar and proxy deployments and instead deployed strategic gateways at network boundaries? This, on the HAProxy side, is what we call the universal mesh. So if you take a look at it, this is a mock-up, but if it's basically, you can have an outer edge and an inner edge because HAProxy is omnidirectional, so it could do north-south or east-west. And you could take, on the outer edge, some of the most popular things are TLS termination, security, centralized logging, rate limiting. And on the inner edge, it's mostly east-west traffic. So think about rate limiting, think about traffic splitting, other complexities that you see in today's modern infrastructure. So to sum it up, essentially, our universal mesh is simpler, flexible, and a more powerful architecture backed by HAProxy with 20 years of proven reverse proxy excellence. We focus on convergence, federation, and that gives you the universal mesh. So on the convergence side, it's the ingress, the mesh, and proxies all become one. It's one HAProxy managing that. Federation, it's out of the box. We built federation with this in mind, so it's effortless multi-cluster or multi-cloud or multi-region, and that gives you unified security, connectivity, and observability, which is the primary purpose of the mesh.
Frank, I would just add that I think that the multi-cloud kind of connectivity and multi-cluster connectivity problem is real. I don't know if you've noticed, but AWS announced, I think today morning, that they have a new solution called Multi-Connect or something like that, where they're actually partnering with GCP to do connectivity between AWS, GCP, and then other networks. So something that you were able to do before, but now there's a single API call to connect all of these clouds. And they operate on a layer 3, so different than us, but this kind of shows you how much demand there is for basically multi-cloud, multi-connect, multi-cluster connectivity, because everybody's trying to solve this problem.
So we think the universal mesh solves impossible problems. It connects everything. It's a single pattern that simplifies operational complexity and resource utilization. It's multi-cluster and federation ready. So it understands resources, it understands infrastructure, spans cluster, without forcing architectural compromises. It's the same pattern everywhere, and there's flexible deployment. You can run gateways external to Kubernetes, inside EC2 instances, EKS, ECS. It's really flexible. So if you want to take a look at this, is kind of a typical mock-up of an architecture diagram. You'd have the control plane, which is Fusion. All service meshes kind of have, they're broken up with a control plane and a data plane. And then you'd have the data plane layer, which is HAProxy, which empowers all of the features that you can see on the side. And this is proxying to any number of services. If we're talking about AWS, you can use ECS, Elastic Container Service, EC2, auto-scaling groups as well, Kubernetes, basically anything we can route to anything, and then we can also do the same for any virtual machine or any on-premise or any other region. It's basically all controlled through the control plane in a single management plane. So that gives you kind of the building blocks of a modern mesh. On the inside, you want to talk. The most important features are you're looking for performance, you're looking for zero trust, you're looking for multi-layered security, authentication and authorization, and federation again as well. So let's dive into our sweet spot. We are the world's fastest application delivery and security platform, and we do have the proof to back it up. In 2021, we released our article showing that you can achieve 2 million requests per second on a single AWS instance. It was a Graviton 2 at the time, and basically this has been never seen. So it's really sheer performance, and it's one of the core tenets of HAProxy. In everything that we deliver, it's performance, reliability, and scalability. All of that is in mind. What happened though is after that release, in 2023, we realized there was a dramatic performance loss in the new LTS version of the current TLS library we were using, and efforts with the authors failed to yield acceptable results. So what did we do? In 2024, we reworked our entire TLS stack to support modern TLS libraries, and in 2025, we released a performance build using AWS LC. That was the library we selected as the default TLS library, and we also have modern alternative support, so compatibility supports for anything that's delivered by the OS as well, if you want to use that. And it's always our commitment is to do whatever it takes to deliver the best performance. And then we didn't really release a benchmark, but we just released HAProxy 3.3, and we're sharing some of our internal benchmarks. So what we've done is we did the exact same test that we did in 2021, and obviously the natural sentiment would think, oh, since 2021, the hardware has become so much more powerful. You should see an increase. But the reality in today's world, since 2021 to 2025, we've actually released 10 separate versions. And what you're seeing in modern software is the phenomenon of software bloat. Every release has more features, it takes more resources, so it basically takes away from the advantages that you're gaining from the hardware. So what we saw when we benched it on the exact same test, right now it's pretty much the exact same instance, except it's the Graviton 4, the most recent Graviton that's been released. We were able to achieve 2.54 million requests per second. And to make sure that we're testing on the same platform, we reran the exact same version on the exact instance, so it's not anything related to hardware. So we took the same instance, we ran 3.3, then we ran 2.3, which is the one we ran at the time, and we yielded better results. But however, the reality is that even in 2021, we reached hardware limitations. So when you're doing such benchmarks, you're really limited by the communication in the internal CPU cache, right? So if you're doing millions of operations, the CPU cache and the communication between it, there's some resource problems. They're just not there yet on the chips. And then you're also limited by the network packets per second. So even on the most modern CPUs, there's only 16 network queues available, and that does seem like a lot, but when you're talking 4 to 5 million packets per second, there's a lot of chances that stuff gets into user land, so it's consuming resources. So what we decided, because we were reaching the hardware, we decided that instead of trying to go for a bigger number, because in reality, nobody really needs this much traffic, or if you do, it's great to have something that does it on a single instance, but we fixed other pieces of our architecture, such as we optimized more load balancing algorithms, so our least con algorithm, our default algorithms, we switched it from round robin to random, and we focused on a lot of tuning in our queues and in our counters to help with other bottlenecks. Because once you're at the reverse proxy level, you're load balancing traffic in front of application servers, and most people provision their application servers not to full utilization. So if you can use the load balancer to get more efficiency on your entire farm of application servers, then you're really gaining overall. So our queuing system really allows you to utilize 100% performance of your application servers. So we're not only empowering performance on the load balancer level, we're empowering performance on your entire application level as well. And then if I'm on the other side of the fence and I'm actually running something that needs 2 million requests per second or more, I want to know how much that costs, right? That's really the most important. If you go to your CTO, he's going to ask you, how much will it cost me to actually run this entire workload? And if you look at the quick back of the napkin math, you can realize that a billion requests actually costs 41 cents on this instance type. And we've benched it that we can get it down to something on the 20-cent range if you don't need these amount of cores, 64 cores and that stuff. So all this to say that when it comes to performance, there's nothing that can match HAProxy.
I would say, Frank, notice the C8GN instances. My team actually benchmarks all instances on AWS with HAProxy, and we are a very network-heavy application, and so if you go with like C8G instances, you will very quickly run out of network limits. So notice that a lot of the benchmarks use C8GN instances with the network optimized cards, because otherwise you're going to run out of PPS limits and bandwidth limit exceeded and everything else on the instances. So in these cases, it's very important to use the GN instances. And as you can see, we're very big fans of the Graviton ones as well. So they're the sweet spot for HAProxy.
Then it comes to federation. So to HAProxy, an IP is an IP as long as it's routable. So that empowers us to use the control plane to configure each of our proxies independently. So if you take a look at this picture, the control plane can send a different configuration to US East and to US West to each one of those instances. However, since the control plane knows about US East and US West, it can also send that information to all the proxies. So if there's ever a situation, and we have a lot of use cases like on the payment provider side where people are looking for redundancy or backup, so when a transaction costs money, and if there is a failure, there are no servers available in a single instance, they do want to cross over, even though it may cost a monetary value. All of these things, having the control plane outside, talking to the infrastructure and being aware of the infrastructure really enables flexibility and allows us to be truly any platform, any service, any infrastructure. And a lot of the use cases that we see take full advantage of this. If you take a look at, we have an ad tech recommendation for HAProxy in partnership with AWS. We've worked with a lot of the 5G or mobile providers to really expand their coverage in wavelength zones for AWS, where we install our own software, and then we discover resources for the 5G Kubernetes cluster, and basically we offer native load balancing for a 5G network in a remote region where there's only wavelength zones. And then, as I mentioned, on payment provider side, a lot of payment providers nowadays, popular ones that you can take a look at our website, basically they have redundancy across 3 or 4 different regions or zones, and they want to switch over. They want region affinity, so they want to stay on the first one as much as possible. But in the event of a service failure, they allow them to cross over, and they want us to prioritize which ones to cross over to, and that's all configurable out of the control plane and out of the configuration. Then a key point of a service mesh is zero trust. So in terms of TLS, in terms of certificates, this is all handled between HAProxy and the control plane itself, either renewing the certificates, accepting, verifying the certificates, even on health checks to the backend servers, client certificates, CA certificates. All that stuff is handled out of the box with HAProxy, and then we slide back to the slide before. You look at the performance. We optimize performance at level, and we monitor it. As I mentioned before, we even moved to AWS LC, which is kind of giving us more options on the new types of quanto encryption and stuff like that. Haven't seen many use cases yet, but we're trying to move to a modern TLS library that can enable these workloads in the future. And we're always on the precipice of new technology. We just released our experimental version of kernel TLS and encrypted client hello. So we're really being on the forefront of all these platforms and all these RFCs. Then another piece that's really interesting when it comes to a service mesh is really authentication and authorization. Basically, this diagram kind of shows you how authentication and SSO modules work. We do have modules on the enterprise side. We can handle anything from OpenID, SAML. We even have ADF's proxy protocol as well. There's a specific Microsoft standard for ADFS. We have a module for that. But in theory, basically, client presents itself to HAProxy. HAProxy can redirect or talk to the IDP in the background, and then pass on that information to the backend server. So it's kind of seamless. Then you just maybe you have APIs or you're using JWTs. We have native support for JSON and JWTs. So basically, these functions can help you find the algorithm, the issuer, the expiry, the scope. All that information can all be natively done inside of HAProxy and has been for a while. And then you can, based on what you find, you can actually deny, approve, and you can build your own access control list on that side.
As a side note, HAProxy 3.3 that was released last week.
Last week, yeah.
Last week added support for JWE tokens. So those are the encrypted JWT tokens. So you can actually now not just verify JWT tokens, but you can decrypt them first and then verify them. So that was added to 3.3.
Exactly. And then sometimes you want to have a language based on the results that you're going to get, and we see a lot of it in the field. We see a lot of OPA, so Open Policy Agent. So we do have support for that as well. So if you need more complex policies, you can define a policy in Rego, and basically we parse the input and we decide to allow it or not based on that. So it's really super flexible in terms of authentication and authorization. And then I'm going to hand it over to Jacob to go over our multi-layered security capabilities.
Thank you. So I'm going to talk about multi-layered security and really first introduce what it means to me to talk about multi-layered security. And then I'll talk about how we're achieving that in HAProxy. In context of performance, right? Because you've noticed that we talk about performance a lot because in many cases, security means performance implications, and we don't think that should be true, right? So to me, multi-layered security means a lot combined with authentication, authorization, everything that Frank talked about, but also detecting application layer DDoS attacks, web scraping, brute forcing, common spam, vulnerability scanning, some specific targeted exploitation, and I'm going to talk about the details here. The web scraping, to me, is one of the most important ones because obviously with AI, since we're all using AI, right, there are a lot of websites out there announcing they're struggling with AI bots scraping all of their sites. And there are many protections, and you can definitely use protections from HAProxy, but there are many others to stop AI bots from scraping your site while you're fighting some targeted attacks from AI scrapers that are just trying to get everything from your website. So I usually define this as multiple layers of detection and decisioning. And the reality is that I'm going to talk about these layers as 4 separate layers, but they all actually work at the same time. So the fact that I have chosen to place these layers in this order is just my choice, right? In the end, all of what I'm going to talk about happens at the same time. So I should be able to choose which layer reacts first, or just do all of the detection first, and then make a decision later, with some exceptions, right? Because, for example, here we're applying access control. So if I'm applying the access control, and for example, I'm deny listing a specific IP address, well, if I've deny listed an IP address, it doesn't make sense to try to detect if it's a bot or not. It doesn't matter to me. I'm going to deny it anyway, right? So I can just deny right away. So access control, like deny specific IP addresses, allow internal IP addresses, allow specific monitoring systems, or deny specific fingerprints or IP addresses coming from bots, right? This is where we're kind of starting that idea of the bots. The idea that we use in HAProxy, and this is thanks to the HAProxy community support for large files, is that you can actually put millions of IP addresses inside HAProxy and say, deny based on this list. And looking up that IP address in that list, whether you're looking up the first one or the number 1 million, will take a constant amount of time. So you don't have to worry about how to scale for a large amount of IP address blocks. This is all thanks to Willie Taros, who's the founder of HAProxy, created this unique data structure called elastic binary tree. I recommend that write-up if you ever Google elastic binary tree. He has a big write-up on how it works and how it scales to millions of items. Then I start rate calculation. So I'm not denying, but I'm calculating specific rates. And even here, I'm saying, is it over a rate limit? But I don't care if it's over a rate limit yet. I'm just calculating a rate, right? So I'm figuring out, based on an IP address, bandwidth, label of a bot, URL, what's the rate of the requests from this specific client? So rate limit is all about grouping clients or identifying individual clients and saying what's the rate of their requests so I can make decisions later. The problem is that in our experience, static limits are hard, and we think there's a better way. I don't know if you've ever ran rate limit in practice in your own HAProxy or any other reverse proxy, but every time, I think Frank, in production, you ran this, right? Every time you set up rate limits, you get it wrong, every single time. And now you don't know what the rate limits should be, right? Should it be 100 requests a second, 1,000 requests a second? What if my traffic is normally 100 requests a second, but I spike to 1,000 requests a second every day during a specific hour? Then I have to set the rate limit up to that specific very high rate, right? But then I can be attacked during the low traffic periods. So we've built something we call a global profiling engine that allows me to aggregate statistics and aggregate rates across multiple instances of HAProxy, and then calculate statistical aggregation. So I can do things like, hey, I'm going to rate limit bots over 1.5, the 95th percentile of the rate, same hour yesterday. So I take a look at what's the rate of the requests during the same hour yesterday, and then I take a 95th percentile of that, and that's a specific number. And I don't want to probably block or deny on that specific number, because that's a 95th percentile, right? But let's decide on a ratio, 1.5, 2, depending on who it is. And I start blocking on that, or rate limiting on that. And that gives me dynamic rate limit. So I no longer have to set static rate limits. I do it dynamically. And basically, the rate limit actually changes every hour, or every second, or every 5 seconds, depending on how I set it up. Next is bot detection. There are a lot of bots out there. There are bot scraping companies at the expo right next to us selling bot solutions, right? And so the reality is that a lot of people want to detect if the request came from a bot or not. And I'm not saying that if the request came from a bot, that's a bad thing. It might not be a bad thing for your specific situation, right? But maybe you need to know. And you need to be able to identify those and identify crawlers, and that's the AI thing right now, right? Can you identify crawlers that are based on AI? There are good companies out there that will say, hey, I'm OpenAI, right? And there are bad companies out there that will hide they're an AI scraper and try to hide that from you so they present themselves as a standard browser while it's one of the top 4, top 5 AI companies out there. I'm not going to name there. And then, so think about this. I did access control. I determined rates. I determined if it's a bot or not. Now I need to do some security in terms of attacks, right? So I should run a web application firewall. And the problem with web application firewalls usually is latency and throughput. So if you just enable standard web application firewall, like one of the open source versions, you will find out that your latency goes up and your throughput on your reverse proxies goes down because it just takes a lot to actually detect the traffic. So we actually built a WAF with a latency that is not detectable. So we had our own conference, and we had a customer of ours came in and said, we enabled the WAF, and then we got confused because it felt like nothing happened, because they couldn't detect a statistical difference in first time to byte when they enabled the WAF. And then I did a lot of detection. And the reality is, as I mentioned, you should decide early in specific situations. If an IP address is on a deny list, well, deny it right away. We don't need to go all through the hassle of bot detection, WAF filter, and everything else. Deny it right away, right? So you can do some early decisioning. But very often, we see the customers do decisioning later once they do all of the detection. And they decide on a response. So I can deny the request, I can allow it, I can target it. That's a very popular thing where, for example, on our network, I don't know if you want to mention that, we target customers or bots or bad clients instead of denying them. Because if we deny them, they will detect we've denied them, and they will adjust, right? So we target them instead.
Yeah, blocking is not something we often see, or people usually have options to do. So it takes a lot of decisions on the product side, or as an organization has to go through change requests and stuff like that. So it's not something we see commonly. So we do offer you the ability to make any decision, right? Or label it, observe it, and make the decision later. So it's completely configurable, and that's some of the power that we're offering as well.
Yeah, most of our customers target or send traffic to limited backend. So like if you have a backend with your real servers that can handle 10,000 requests a second, they'll send the bad behavior to a backend that can handle 100 requests a second. So the users will not get blocked. The bad users will not get blocked. But at some point, they're going to run out of resources and think, oh, I succeeded. I brought your website down. And they might stop, right? But in the end, your normal users are still going through the fast backend because you just limited the bad behavior. So you don't show the users, the bad users, what happened and what you're doing. Because again, once you start blocking them, our experience is that they start adjusting. And so you will be playing a cat and mouse. The other thing that very often we see is show a CAPTCHA or some kind of a challenge. This is one of the popular solutions recently. I don't know if you've heard of like JavaScript challenges, Anubis, and a few others, which is really, I'm going to allow the request, but I'm going to ask you to calculate 2 prime numbers first. And I want you to take 500 milliseconds doing that, right? To slow them down with the idea of, I'm not going to block them, but I want to make it a little bit more expensive for them to succeed, to kind of reduce the amount of traffic they can run. And then again, we said, we're taking all of the layers and we're making business decisions now. And this is the important part. You should not let anybody to say, hey, this is what you should do. It's a business decision to allow a request or to deny a request or block a bot or give them a JavaScript challenge. And then finally, we route them, right? And so we're a reverse proxy, we're a load balancer. So we route the requests, but we augment them with data. So geo-IP data, we rewrite the headers, device information, and a few things like that. And some of the standard routing you're used to from reverse proxies, like based on SNI, cookies, path, or anything else in the request. We uniquely have access to the entire HTTP request, right? So we can decide how to route. We can decide to route on an AI model. If the request is for a specific AI model, we can route it to a different backend based on the data in the request itself. So again, the idea is that we're going to protect against application layer attacks, web scrapers, brute forces, spam, on forms and everything else, targeted exploitation, scanning, and everything else. I talked about this actually last year at a different conference, but there are obviously edge cases to this, right? At the edge, as I call it. So, for example, LLMs. Everybody's doing vibe coding now. Everybody's doing AI. And the idea of securing AI is pretty unique and new. So we're seeing customers doing new kind of protections like rate limiting based on tokens instead of requests, because requests are cheap, tokens are expensive. PII detection, this is very prevalent in like big enterprises where they don't want to send PII to the AI. They don't want to output PII, right? But most likely, most often they don't want to send the PII to the AI. So they want to detect that as quickly as possible and figure out if there's any PII and block the request. And then API key protection, which is standard API gateway. So I'm going to show you an example implementation of this. And then actually when I do my demo, I'll show you everything running. But this is an implementation that I did myself. You don't have to implement the same thing. You can if you want, but I did it myself. So I've decided that we're going to do a couple of things. We're going to deny, rate limit, challenge, sandbox, and then allow. And so I'm deny listing bots and IP addresses that are on a specific list. I'm deny listing anybody who's triggering a WAF over 3 triggers. That's a human. This is another thing that we've noticed. Even our largest customers, very often they say, you know what, we're running a WAF. We don't want to block traffic, even with the WAF, because that's a big decision. So they allow 1 or 2 violations to go through before they start deny listing the traffic. So if I'm a human, I can trigger the WAF once, twice, but 3 times, then I'm gonna be deny listed. So we see that all the time. Rate limit bots over a specific anomalous threshold, right? Like very often what I do is allow humans to do 3x the 95th percentile, allow suspicious clients to do 2x, and allow bots 1.5, right? So humans have the most leeway in terms of how much rate they can actually run, versus bots have the least amount of leeway.
And in today's day and age, you kind of have to have both sides of the coin. You have to have reputational signals, which we're providing here as well, but you also have to have behavioral, because with AI and agents nowadays, it's almost undetectable, headless browsers and these types of things. So you need a lot of combinations, and this allows you to kind of perform that with all of our tools.
Yeah, absolutely. And so we talked about the what, and let's talk a little bit more about the how. So this is how we do the configuration, and this is how we show our customers how to do the configuration. And we ultimately centralize everything into the control plane. And with the control plane, we centralize all of the policies, so you can then deploy them across all of your public clouds, VMs, on-premises, Kubernetes, and anywhere else. And the way we do it is through a unified control plane, where you basically deploy configuration once, and it's deployed to all of your HAProxy instances. And you apply security profiles. So think about like all of the security that you need to configure on all of the configuration. When I first made the security recipe I've shown you before, it was like 200 lines of configuration. It was not code, but it was configuration. We've abstracted away that specific configuration to a security profile. So I can basically on the left add all the signals. Those are the detections. And on the right, I do all of the decisions, right? So on the left, I say, hey, is this web scraping? On the right, I decide what's the decision I'm going to take to actually react to the web scraping. And when I do that, I can then deploy the security profile to all of my instances. So again, our customers don't run 1 or 2 instances of load balancers. They run hundreds across all of the clouds, all of their on-premise infrastructure, all of their regions, all of their availability zones as well, because sometimes they try to avoid cross-AZ traffic for many purposes. So basically, I take all of the steps on the left, again, and I decide what are the decisions on the right to take. And very quickly, I'm actually going to get to this, and then I can start inspecting what's going to happen to the traffic. So in this case, you can see I think this was a screenshot I took for the last 5 minutes. So in the last 5 minutes, we saw 65,000 requests. We allowed about 46%, so 30,000 of them. And we took an action on about half of that as well. And notice we're calling it taking an action, because we can't say we denied something. We don't know in advance what's the action we're going to take, right? And in this case, the action, in this case, the action was we're going to target some brute force attacks. We're going to deny high-risk countries and everything else. So that's the actual action that we're taking. So Frank, do you want to talk a little bit about some of the service patterns we've seen?
And again, all these patterns, again, they're all possible with HAProxy. It's just a question of configuration. So you see the common ones that we have are on the API gateway or circuit breaker within an API gateway. And then basically you'll see the users they'll be hitting HAProxy, and then you'll have SSL termination, rate limiting or throttling as you've seen before, and different microservices or circuit breakers if services down or if they're consuming too much time. And then you have other traffic splitting initiatives, which are kind of like simple weight-based or other value-based. So like a typical canary deployment. So if you're sending 10% of traffic to version B, but your stable version is version A, if you're in Kubernetes, you can roll deployments and these types of things. Blue-green is similar. So you have a blue cluster, a green cluster. HAProxy makes the decision based on the value, however you pass it to it, and then it switches over the traffic. And it's really flexible. It's really flexible for any pattern. Again, the whole point of this, the control plane makes it a lot simpler. All this configuration is all possible in HAProxy. Control plane gives you API and client libraries to be able to simply do this and make it more seamless and apply it to different clusters. And now there's been a lot of talk. Thank you for your patience. But let's see some of this in action.
Cool, thank you. So we introduced a couple of concepts, right? We introduced the concept of universal mesh. We introduced the concept of security. And so traffic through the universal mesh flows through either externally, that's the north-south traffic, or internally, that's the east-west traffic, and I'm going to talk about it later. So imagine that you're an Acme Corp, and you're running a universal mesh on mesh.acme.com. And the point is that we're doing explicit routing of traffic. So if I'm a service, or if I'm a user out there, either an external user or you're mapping to some public domain, you want to talk to a payment gateway that's on premise, right? You're going to call mesh.acme.com/payment gateway. And what's going to happen is your first HAProxy will ask, hey, where's payment gateway? And we'll find out, payment gateway is on this HAProxy that's on premise. So we'll send the traffic there. And the HAProxy on premise receives this traffic and says, where's payment gateway? Oh, that's this pod in this on-premise Kubernetes cluster. And we'll send it there. Compared to internal traffic, which actually looks exactly the same. If I'm a service in a pod in US West 1 in AWS, and I want to talk to the payment gateway on premise, I do the same thing. I call mesh.acme.com/payment gateway, and the HAProxy that's closest to me will find out where's payment gateway. It's on premise in this specific data center. We'll send it there, and that HAProxy will send the traffic there again. So I've made a demo of exactly this. So if you want to scan this, I hope the QR code still works. If you want to scan this, it's the page that I'm going to show now. So you should arrive on this page, meshhappydemo.com/payment gateway. Right? So now I'm sending traffic externally from my browser to the universal mesh and back to, this is actually a pod in a Kubernetes cluster. So if I load this page, I get an answer. And this is because, again, the external HAProxy decides what's happening, finds out where to go with the traffic, and then sends the traffic over. What I'm going to do is I'm going to hack myself. So I'm going to say path equals etc password. There's a path argument, and if you give it a path of a file, it will give you the file. It's kind of fun, right? So you can do that, but obviously that's not going to work because this is a demo. So you get 403 forbidden. So let's take a look at what happens in the background, right? How's this traffic being routed? So I'm going to go to the control plane for HAProxy, and the first thing I'm going to see is there's this request, payment gateway, or path equals etc password. So that's the one, and you can see we got a 403 response. But when I go to the detail, we actually took an action. And the action was we blocked this request because we deemed it suspicious as a client. And at the same time, it triggered the web application firewall. So that was my business decision, right? I talked about the business decisions. And my business decision is if it's a suspicious client, then do more than to humans. And you can see the bot management said that this is a suspicious client because I have some things in my browser installed that made me look suspicious. So as a suspicious client, we decided to block this. And we triggered an obvious probe with the path etc password. That's pretty obvious, right? So we don't have to talk about that much more. The other thing that we're going to look at is instead of looking at the specific request that we blocked, let's actually take a look at the request that worked, right? Some of you actually loaded these. So some of you will be these specific URLs. Obviously, I can't say who's who in the audience, right? So somebody requested /payment gateway, and we routed this request to US East. That's the HAProxy inside US East. And then we traversed to the other HAProxy, and I want to know what happened to that. So what I'm going to do is I'm going to click on the search here next to the correlation ID. So now you see the two requests as they traverse the network. And in fact, to the client, this is a single request, right? But we see it as two, because the first one right from the client to the HAProxy. The second was from the HAProxy to the far end HAProxy that originates, or that's the destination of this traffic. And that's this one. And in here, we're sending the traffic to this specific payment gateway service in Kubernetes. If I make this even bigger, you can see that, right? So I'm automatically detecting all services inside my Kubernetes clusters. And here, I'm sending the traffic to this specific Kubernetes cluster. The last thing I'm going to demo on this is we're actually going to do some terminal work. And I'm going to deploy a new demo. So here, if you take a look, if it lets me through. If you take a look, I have this new manifest. And I'm calling this manifest demo 1, right? And this manifest says that I'm going to deploy a new service, and the path of the service should be /demo1 in the US East. And at the top of it, I have some web server with just basic information. So I actually applied it before, but I'm going to reapply it in my Kubernetes cluster. So I've created the service. I've created the deployment. So if you take a look, I have some pods of the deployment, demo 1. So that's running. I can actually scale the deployment. I think it was called demo 1. So give it 3 replicas instead. But now if I go to mesh-happydemo.com, I actually get an answer. And the point is that the HTML is the same as the previous service, right? But suddenly, without me doing anything, just by deploying a service in Kubernetes and saying, hey, service path should be /demo1, every client in the network and every HAProxy now knows how to route demo 1. So if I now go to mesh-happydemo.com /demo1 from externally in this case and internally at the same time, I arrive on the pods of this specific service. And if I scale the pods, again, if I change the number of the replicas, if I change the number of the replicas, then this will be automatically updated, and I will be sending traffic to the 5 replicas now instead of the 3 replicas that I had before. So just to recap, we talked about service discovery and basically creating services inside Kubernetes and automatically configuring them in HAProxy and running multi-layered security on top of them where I'm observing in the control plane what's happening. And we think that this is really a solution to the connectivity problems that a lot of our customers are having in terms of talking between services inside AWS, but also AWS to GCP and a few other clouds that they're seeing out there, and they're requesting solutions for that. And Frank, I don't know if you want to close us up?
Oh, in the end, just, oops, you want to just go up?
Yeah, there you go.
We just want to say thank you, and you can come see us at booth 1179, and you can visit HAProxy to see some of our other solutions as well. But in general, we're happy to discuss. And just another thing, all these things are available. HAProxy is available in the marketplace in AMI. So it's definitely any form factor, everything works. And if you have any questions, feel free to come and see us. And thank you for your time.
Thank you.